This week on the Tech ONTAP Podcast, we cover storage efficiency as well as the new FlexCache updates for ONTAP 9.12.1.
Welcome to the Tech ONTAP Podcast with Justin Parisi.
I love NetApp.
Oh, yeah.
NetApp. I love this company. Support.
I love NetApp because it's so funny.
Hello and welcome to the Tech ONTAP Podcast. My name is Justin Parisi. I'm here in the basement of my house, and with me today I have a couple of special guests to talk to us about some new functionality in ONTAP 9.12.1, as well as some stuff that we haven't really covered before for ONTAP. So with us today we have Elliott Ecton. Elliott, what do you do here at NetApp, and how do we reach you?
Hey, Justin. I'm a technical marketing engineer for NAS protocols. Kind of took over, slid into your old spot a little bit. If you want to get a hold of me, you can email me at elliott.ecton@netapp.com.
All right. Also with us today, Chris Hurley. Chris, what do you do here at NetApp, and how do we reach you?
Hey, Justin. So I am a senior technical product manager for ONTAP here at NetApp, and you can reach me on Twitter at AverageGuyX, and of course my NetApp email, so christopher.hurley@netapp.com.
All right, excellent. So we're here to talk about some NAS-related stuff. Specifically, we'll talk about some FlexCache advancements, but let's start off with storage efficiency. We've not really gone into a lot of detail about some of the newer stuff that's been in ONTAP in the last few releases. So, Chris, what have we done in the last few releases with storage efficiency, and when did we start doing it?
Yeah, so in ONTAP 9.8, we introduced something called TSSE, so temperature-sensitive storage efficiency. So what that means is your cold data, we're going to take and recompress it with a larger compression group. So you get a little more savings on your colder data. Of course, that's going to give you a little less performance when you're reading that cold data that's already compressed, but it's cold data, right? About 14 days is the threshold. So that's going to do in the larger compression group. Now that was 9.8, but in 9.10, we actually added a more aggressive compression algorithm. So Z standard compression, which is, I don't know if everybody knows the Facebook Z standard compression algorithm, but we're using that to actually compress the cold data and get a lot more savings out of it.
Okay, so it sounds like that we're looking at storage efficiency from a different perspective than we used to, where basically you're taking the concept of, is data active? But what happens if we start to access that data later on? Like, is that going to have some impact, or what is that going to do?
Yeah, it is, right? So you're especially because we're using the larger compression groups, when you're doing small reads of that cold data, you're going to have to read the whole compression group, right? So there's a little bit of a penalty there, but if you do it enough times, well, there is a mechanism to uncompress it back to the smaller compression group. You still get some savings, but it allows for ONTAP to eliminate that penalty as much as possible.
So can you kind of tell me a little bit more about these compression groups? Like, what are the main differences? And is it something that I can modify later on? Can I make the compression group work differently, or is it just something that's baked into ONTAP?
It's basically something that's baked into ONTAP. So by default, inline, what we do is we take data and look at 8K chunks of it, right? You know, ONTAP writes in 4K blocks. So we look at 8K chunks of it. And if we can compress that down, of course, into only one 4K block, we're only going to consume one 4K block in ONTAP. Now, in the TSSE model, after 14 days, we'll relook at that data and then use 32K compression blocks. And that way, if we can compress 8 4K blocks down to 7 4K blocks, or 6 or 5 or even less, right? That's even more savings. So those larger compression groups from 8K inline to 32K cold TSSE compression groups, that's where you get your savings. And of course, the Z standard compression algorithm on that cold data.
So what kind of storage savings can I get out of this? How much does it improve how much I save from previous ways we did it?
Well, it all depends, right? Every data set has its own compressibility. But by default, the Z standard algorithm has a lot more in its compression algorithm than what we normally use in ONTAP, which is LZO Pro. And that is also what we use for the inline 8K. I hate to put down a number, but there is some significant increase in the data reduction with Z standard.
And what sort of workloads see better overall results? Like, I know that some workloads are going to be more efficient than others. Where would you see more compression savings versus less compression savings?
So things with repetitive patterns, of course, like VDI and VMware and those type of workloads would greatly increase their data reduction with the Z standard compression, but others as well, because the compression algorithms, as they mature, they are able to compress more and different types of data. So as the version increases of that compression algorithm, you're going to be able to compress more and more data.
So that sounds pretty cool. Are we looking at even further advancements with compression algorithms? Are we going to add any new things in the future? I mean, I know you can't commit to things, but is that something that we're looking at?
Oh, absolutely. We're always looking to improve on that, right? Because what does that translate to? That translates to savings for our customers, right? If you want to store 100 terabytes worth of logical data and you get a 3-to-1 compression ratio, then you only need, 33 terabytes of storage, and you can store 100 terabytes of data. That's a benefit to our customers. Now, like I said, we're always looking at something new, bringing that to the next level, and finding new ways to reduce the data in ONTAP. So A, you don't have to buy as much storage to store the same amount of logical data, and B, maybe even get some performance increase for new technologies for the storage efficiency.
Are we still doing that guaranteed storage efficiency deal where we basically say you're going to get 3-to-1 or 4-to-1 with certain workloads? Is that something that we're still doing today?
Yeah, we are. We've recently also changed that to a blanket 4-to-1 guarantee for SAN workloads. So anything that you run SAN protocol on, your block storage, will get a 4-to-1 guarantee by default when you enter the program. And for NAS, it is 1.5-to-1 on that same program.
So why is there such a big discrepancy between SAN and NAS for those particular storage efficiency ratios?
NAS, of course, everybody knows things called unstructured data, right? And that data compressibility and dedupability is a lot less than your structured data workloads, your Oracles, your MS SQL, your VMwares, and anything else that runs on the block protocol. So we have to account for those things.
All right. So it sounds like storage efficiency is pretty good at this point, or getting better with each release. So one feature that we actually have that kind of, I wouldn't say it's a storage efficiency feature, but it helps save space because you're not creating additional data sets. You're basically just creating a sparse cache, and that's going to connect to an origin data set. So, instead of creating an exact replica of, say, 100 terabytes, you're creating maybe a cache that's 1 gig or 2 gigs or 10 gigs, whatever, right? So that's traditionally been for mostly reads, and that's FlexCache. Now we have a new feature in ONTAP 9.12.1 that allows us to do even more with the FlexCache architecture. So what is that, Chris?
So we've got what we're calling write performance. It's not quite write back. So FlexCache, as you mentioned, right, it's a sparse read-writable volume. But up until now, when you write at a FlexCache, that write gets transferred all the way over the wire to the origin and has to be acknowledged by the origin before it can be acknowledged back to the client. Well, with 9.12.1, we now have the ability to acknowledge that write and store it locally at the FlexCache volume and acknowledge that immediately to the client that's writing to the FlexCache volume without having to wait for that traversal all the way to the origin.
So you said it's not quite write back, but that's what we're calling it. So why is it not write back? Why is it just write performance?
Well, the origin still has to be involved with inode creation, so file creations, and it also still has to be involved with opens, locking and that sort of thing. So the main operations that are actually accelerated are the actual write operations.
So with a FlexCache, you might have multiple caches pointing at a single origin. And I would imagine that applications that leverage the write back or the write performance aspect of it are going to have multiple writes going to the same files in some cases. So how is that handled?
It's handled very similarly to how it's handled today, right? So we have the write lock delegations that come to each cache. And then only once that write lock delegation needs to be revoked by the origin, the cache also needs to flush the temporary data that has been written at the cache. So you look at the write lock distribution, the way it sits now in FlexCache, it just means that the write lock stays a little longer at the cache. And so in order for it to be able to write at the cache and then flush it back to the origin when that write lock is revoked.
And how is it handled on the origin if we're changing the files there? Does the cache get evicted, or is there a lock in place then as well?
Let's say you're writing at cache 1. As soon as there's a write request from either the origin or another, the origin is going to ask for that write lock back at the cache where that file is being written to. And at that point, once the cache does relinquish that write lock, that's when the data gets flushed. So the next write can happen, and that lock will go back to the origin or to the other cache. So it keeps it all in order that way.
So let's say there's a weird, rare event where 3 clients have 3 caches, and they're all trying to write to the same file. And at the same time, we're writing a file in the origin. Who wins there?
The one who has the write lock, right?
Okay.
That's the only way you can write is if you have the write lock to the file. Now, there is one of those weird scenarios where as you're writing, there's some disconnection that happens, right? And at that point, you have the option to go ahead with write somewhere else because basically the file is held hostage by the disconnected cache. But then what happens there is you basically lose your rights. You have to force that, though. If you have a disaster and the cache cluster actually goes away and can't come back, you can force that to happen.
So I would imagine that you would just go in and clear the locks from the vServer using like a vServer locks command.
It's not quite a vServer locks, it's a FlexCache command, but yeah,
okay.
Same concept.
Okay. And viewing those locks, would that also be a FlexCache command, or is that a vServer locks command?
That is a vServer locks command.
Okay. So what happens if I run a vServer locks command to clear the lock? Is that going to not allow it to clear on the FlexCache, or does that override whatever's on the FlexCache lock command?
Well, normally the locks are flushed, right? Normal lock operations, you can use vServer locks. But if you need to force a FlexCache to be able to move ahead, you have to use FlexCache commands.
Okay. And is there like a lock timeout period, like a grace period on the FlexCache where those locks will eventually release if they can't be reestablished?
Under normal operations without write back, there is a 2-minute timeout, but that's not for the write back. It is a set it and forget it kind of thing, right? So the lock stays forever unless it needs revoked. But for normal write operations, where the write around operations, because there's nothing pending at the cache, after 2 minutes, there's a timeout and all the locks are revoked for that disconnected cache.
And is there a way to disable the idea of write back to the FlexCache? Like, can you go back to the old behavior? Is there a way to tell it to just do what it used to do, or is that just something that's baked into the new release?
So by default, it stays the same, right? Write back is an option. And we only recommend write back for more than 10 milliseconds of latency between the FlexCache and the origin. Because of the complexity, it provides actually negative performance increase for anything that is less than about 10 milliseconds of latency between the origin and the cache.
Okay, so if you get really low latency between the origin and cache, you're better off just using the old behavior because it's just going to add performance hits that you wouldn't see normally.
Exactly.
All right, it makes sense. So as far as the new feature, from what I understand, it's a public preview in ONTAP 9.12.1, or is that available all the way?
So currently it is a public preview. That just means that feature has gone through only limited testing. We've gone through most regressions, but there are still things that could happen, right? So that's why we're calling it a public preview. But we foresee that we can release it as a GA in a P release after 9.12.1.
Okay, cool. So 9.12.1 will eventually have available for everybody. But in the meantime, you probably don't want to put production workloads on this right now. It's more of a kick the tires thing.
Correct.
Okay. So what sort of use cases are going to get the most benefit out of this? Like, what industries are asking for this type of thing the most?
Well, of course, FlexCache in the EDA is hot, right? And that is really one of those use cases that's really hot and loves to use FlexCache. But it's their cloud bursting, and it's not only EDA, right? It's anything that uses cloud bursting but needs some writes at the cloud. So, traditionally our cloud bursting has more around reading the data from on-prem in the cloud, then doing some work on it, and then just writing back some little results. And that's okay. But there's a lot more use cases to where there are constant writes at the cache during the cloud bursting. So using the cloud as it's supposed to be used for capacity bursting or core bursting or however you want to do it. And that is where the write back actually works a lot better. If you have to do performant writes as you're bursting in the cloud, you don't just need to wait for some results and have that write back, write around all the way to the origin. You want some performant writes in that whole workflow while you're bursting up in the cloud. That's one of the biggest use cases we've seen around this.
Yeah, and I guess you'd be more likely to see that 10 millisecond latency in the cloud versus doing something in a data center.
Right. Yeah, the data center is usually 5 milliseconds or less, or not even 5. And for those, you don't want to use FlexCache write back.
So that said, how would I know what my latency is? Is there an easy way to find out from ONTAP what the latency between the cache and the origin is, or is that something that's hard to figure out?
No, it's actually fairly easy. So in order to create a FlexCache, you have to peer the clusters anyway, right? And ONTAP does have a cluster peer ping command. So you can use that to determine what your latency is between the two clusters.
Okay, cool. So cluster peer ping will tell me roughly what my latency is going to look like and what I should expect for something like FlexCache.
Yep.
And that goes for other things too as well, right? I mean, we're looking at snap mirror and that sort of thing. There's synchronous snap mirror, which also has a requirement of 10 milliseconds or less. So it's not just FlexCache that has this limitation of 10 milliseconds. It's pretty much across the board for any time you're doing something remotely over a WAN.
Yeah, exactly.
And I would imagine this supports both SMB and NFS use cases, including NFS v4?
Absolutely. All the protocols.
Cool. And another thing to add, I know we added ONTAP S3 exposure to NAS volumes. So am I able to expose a FlexCache to object, or do I have to do that to the origin?
Well, as of right now, it's only supported at the origin. We haven't qualified it for use at the cache yet.
All right. And we had something called, I guess, mirroring of caches. Am I imagining that?
What you probably are talking about is the ability to have the same SID and the same file handles between caches. Is that what you're talking about?
It might be. I seem to remember there was some sort of ability to have some sort of cooperation between caches or mirroring of caches. So tell me a little bit more about how we can do that.
So one of the things that you can do is, and we call it FlexCache DR, but it's kind of
that's what it was. It was DR, and it throws you off. That's why I thought it was mirroring. So yes.
Yeah, continue. Exactly. But it's a way for clients to be able to seamlessly move from one cache to another if the cluster were to go down. So when you think of the FlexCache, all the writes are right around, so they end up at the origin, and it's a sparse volume. It's not a critical production thing, right? It is, of course, but in order to best insulate from failures or anything like that, you can create another FlexCache in the same data center or area, right? Logical location. And then what it could do is Both caches will have this exact same file handles. Of course, they have to be in different SVMs, right? If you do it in the same cluster, they have to be in different SVMs. But that way, the NFS client can seamlessly move from one cache to another without getting that pesky stale file handle error.
So how does it handle the network aspect of that? Is it automatic failover, or do you have to remount?
No, you don't have to remount. What you have to do is you either in auto mounter or in DNS or somehow you need to be able to flip your clients to point from one SVM to the other, whether it's in the same cluster or different clusters. That is up to the customer to configure that stuff.
So I know when we mount, we have an IP address established, and that's a TCP connection established. If there's a cache failure, do we have to have the same IP in that SVM, or can we use a different IP address? How does that failover happen? I'm not quite clicking for me there. Like, how do we get that live failover in addition to that?
Well, you can bring the same IP up in different clusters if you want, or different SVMs. Elliott, you've done some work on that, right?
Yeah, I have. So there's a couple ways to do it. One way is if you have two different clusters, you just keep one down, and we'll call it the DR cluster, right? And then when you have a failure to your main site, you would just admin down that IP address and bring it up on the DR cluster, and then traffic will start going to that. So it's pretty seamless, and the NFS clients don't require a remount, and they just keep plugging along.
Okay, so basically you're just using the same IP address, and then we figure it out based on the network. Now, I imagine that MAC addresses are going to be different. So is there any ARP cache clearing that I have to do, or does that client just handle it automatically?
Everything will be updated by gratuitous ARP when the IP goes up. So everything in the network will be updated where the new IP address lays.
Okay, cool. So the IP address comes up, says, hey, I'm here. Here's my new MAC address. Use this instead. Right.
You know, there's more ways to do it than that. That's the simplest way to configure it. But you can also do BGP VIPs and bring up a VIP over there, just other things like that. There's quite a few ways that you can migrate the IP. Load balancers are another way to see if there's liveliness to the IP. Several solutions.
Okay. So you mentioned BGP, and that's something that doesn't get a lot of press, right? It's something that just kind of works. So how would that work in ONTAP? Is there anything special I need to configure for that to work, or is it all on my network side?
So there's very little to do on the ONTAP side. BGPs is a very deep topic, but ONTAP has a very simplistic implementation of it. So to bring up BGP, you need to peer with your routers, and you have to work with your network team to get different ASNs and some IP addresses to establish the BGP peer session. And then you just create a VIP on top of that. And there's no layer 2, right? So it doesn't have to be in a subnet. This VIP just kind of floats where the BGP peer connections are. So it makes it really easy to migrate an IP address from one cluster to another. And when you do that, all your BGP routers, all your BGP peering, most of which your network team has set up, will update the BGP paths to get to the new cluster.
Okay, and it sounds like that might be a little more seamless than having to manually do things on your end.
Yep, exactly.
So this FlexCache DR piece, now I know it's not mirroring necessarily, but with mirroring, we have this concept of read-only access to just destination volumes. Is that something that carries over to FlexCache, or can we do right back to these caches that are doing DR?
Unfortunately, with the FlexCache DR, that is a read-only cache, right? Those aren't available to write just because of the complexity with the MSIDs and those type of things. So yeah, for now it is a read-only cache.
Okay, so just limited use case for now, but still it's valuable, right? I mean, we're able to keep things going and running in case of outage.
Oh yeah, absolutely. Helps for tools distribution, binary distributions, things like that. I mean, it's totally valuable for those.
So as the FlexCache write back goes, is there any other consideration I need to keep in mind, Chris?
Well, yeah. So there's the amount of write back you have in your caches, right? You want to keep that to a minimum. As I mentioned, by default, it is not right because there is some heaviness to it. Right? There is some heaviness to this feature. So you want to use it intelligently and where it's really needed.
Okay. And then with these early access previews, we let customers kick the tires on these. Did you have any customers running this particular feature? And if so, what was their feedback?
Not yet, right? So actually, FlexCache write back isn't going to come in until GA. So 9.12.1 GA is when it actually drops in ONTAP. So as soon as that happens, we're going to get some customers on it and get their feedback. We did get their feedback from the concept, and we got all smiles and all thumbs up.
Okay. And you said it's not in the RC release, it's only in the GA release?
Correct.
Okay. So if I'm spinning up a new ONTAP release, I got to wait for GA to have the access to this.
Mm-hmm. Unfortunately.
I would imagine that we have a technical report to talk about FlexCache. What TR number do we have for that?
That is TR 4743.
It's getting updated soon. It'll have the performance part updated pretty soon by the time GA rolls around.
Will we have any sort of performance numbers that we can look at to see what kind of performance we can expect, or is that just something that you have to kind of test out in your environment?
There is some testing that's going to be going on that is actually going to be starting sometime in the next week or two. So we should have some performance numbers for you to look at.
All right, cool. And yeah, it's just a baseline, right? I get an idea of like, oh, generally this will work. Because I know that every environment is different, but people do like to have some idea if it's going to be better or worse, if it's worth my time. So yeah, all right. So it sounds like a FlexCache write back or write performance, whatever you want to call it, is going to be pretty promising here. And I imagine we're going to build onto things later on in future releases. Again, Chris, if we wanted to reach you, how do we do that?
I am online, Twitter, and other places at AverageGuyX and Christopher.Hurley@NetApp.com.
I am very not much on the social medias, so we'll just do my NetApp email, which is Elliott@NetApp.com. 2 L's, 2 T's, and Elliott.
Cool. We'll include that in the show notes so people don't have to worry about spelling it, and they can just click on the link and email you guys.
All right, that music tells me it's time to go. If you'd like to get in touch with us, send us an email to podcast@netapp.com or send us a tweet @netapp. As always, if you'd like to subscribe, find us on iTunes, Spotify, Google Play, iHeartRadio, SoundCloud, Stitcher, or via TechOntapPodcast.com. If you like the show today, leave us a review. On behalf of the entire Tech ONTAP podcast team, I'd like to thank Elliott Ecton and Chris Hurley for joining us today. As always, thanks for listening.
Oh, yeah. Is it just me that's getting off on this? Oh, yeah.